Alright, so in this video, we are going to evaluate the following integral. The integral of sine to the fifth of x dx. So how do you suppose we evaluate this integral? Well, what we're going to do is we are going to drop the power of 5 to a power of 4. So that would give us sine to the fourth of x, but we still have to multiply another sine of x onto it. And this assures us this times this is sine to the fifth of x. Now what we're going to do is we are going to realize that sine to the fourth of x is really just sine squared of x squared. Right? And we can re-express sine squared of x in terms of cosine squared. Right? If you recall, by the Pythagorean identity, sine squared of x is 1 minus cosine squared of x. And at this point, we can perform a u substitution. We can set u equal to the cosine of x. And therefore, du is just the derivative of cosine. The derivative of cosine is negative sine, and of course we're going to need a dx. If we divide negative 1 on both sides, that'll move the minus sign to the other side, like this. Now notice, we're going to be replacing the cosine of x with u, and the sine x dx with negative du. As a result, that will convert this integral completely in terms of u. So this is our integral. We can pull a minus sign to the outside of the integral. And so really, what we're going to do is we're going to expand this out. And so this is what we would get. And so all we have to do now is use the reverse power rule. Of course, we get a plus c, and then next I'm just going to distribute the minus sign across. We would get this. And so our last step is to replace u with cosine of x. And so this is our final answer. So this would be the answer to the integral of sine to the fifth of x. And so yeah, that's pretty much it for this video.